Well, hi, good morning. It's March 13th here, and I'm ready to go for another run at this radio. Now, if you're watching all these videos, thank you very much. The last video, I chopped a whole hour out. I just dumped a whole hour out of it. And the reason for that was during that hour, I got confused about these two tubes and the schematic, and I did tests. I attributed results to the wrong part of the circuit and blah blah blah, and got myself thoroughly confused. And I thought, boy, if I post that, all it's going to do is it's going to be even more confusing to watch. So the few things I did there was I did some checking of the plate resistors for these two tubes, and I also checked the bias on those two tubes. I'm going to do these things again. I'm not going to check the plate resistors. I don't think there's any issue there. But the two bias tests were a little odd. Oh, I must stop already. Funny how when I'm doing this work I get thrown off track one way or another. So, okay, so what I plan to do today is focus in on the strangeness around this tube. The end result at the end of yesterday's video was an impossible situation. So probably I've done something wrong, I've taken some wrong measurement at some point, and I've got in my hand puzzle pieces that really shouldn't be fit together, because when you fit them together it paints a picture that just can't exist. Be a little more specific. How is it that this tube, both these tubes, the triodes in them are the preamp for the two output tubes. Both of them run at the same plate voltage of 60 volts. They're not identical tubes, but the triodes must be very, very similar in these two tubes. So 60 volts, one of them has 60 volts on it. The other one has, well, according to the test I did, 175 volts on it. The only conceivable way this could happen, given the way the circuit is, and assuming the circuit is what it is, which is an assumption, so I'll talk about it in a second, is for there to be no current flowing through this tube. No current flowing, no voltage drop on the resistors in the plate circuit, therefore the entire plate voltage, or most of it anyway, would show up on the plate here. Why would there be no plate current flowing? Wow, that's a good question. Defective tube? Don't think that's the case. I've tested it again and again. I'm guessing the tube testing for this tube went on the video, but maybe it didn't. I said, what's in that 1 hour that I threw away? I'm not so sure. So I'm not exactly sure what got missed. But I have tested this tube more than once now. It tests just fine. So another possibility is, well, of course, false tests. I took the readings wrong. Boy, I don't think I did, but maybe I did. I don't know where you would have that voltage up on top of this tube extender this tube is plugged into. The highest voltage on here should be 60. Should be the expected plate voltage. Another possibility is an open in the cathode. I took a cathode to ground reading, but that was during the confusing state. Maybe that's on the last video, maybe not. When I did the cathode to ground, it showed 0 ohms, and this cathode is tied to the chassis. The grid biases for these two tubes is curious. Again, I don't know if it went on the last video or not. Let me just get this out here. So these are the two tubes involved. The grid, there is no grid bias. There is no cathode resistor. So what there is, though, is a 10 megohm grid leak resistor, and that suggests to me that what's going on here is self-biasing for these two tubes. And the idea is when the signal's coming in on the grid, initially there's no bias. When the signal goes positive, the grid becomes positive. It becomes a little bit of a plate. It attracts electrons or can absorb electrons out of the inside of the tube. Collects electrons on it. The electron pressure inside the grid begins to go up, so the voltage goes up or down depending upon which way you want to look at it. And as the grid becomes more negative, the grid will become negative enough that the highest positive peak in the signal coming in will not become positive relative to the cathode because of the small grid bias that's developed. The grid leak is there to prevent this charge from just building up on the grid until you have too negative of a grid. So very large grid leak resistor, 10 megohms, that makes things a little tricky to measure. My meter here, correct me if I'm wrong, but I won't hear you. I think the input on this is 1 megohm. I'd have to look to know for sure. It's 1 or 10, one of those two. My scope, when I have the scope leads set to times 10, you get about 10 megohms. Well, that's the same as the grid leak. So when I apply this test equipment, I am knocking down, draining out some of the charge from the grid and getting a false reading. That's what I would say anyway about that. On the diagram here, when it comes to the grid bias, this is where I start getting the tubes mixed up. So right here, and I'm going to check this. I need to check, excuse me, I need to check everything. So it says minus 0.9. The similar tube up here, this is the one that's presenting, this is the one that's up here and is presenting some difficulties. The other tube, this one here, there is no mention of what the grid voltage should be. As the 10 meg, it's all the same otherwise. It's the very same arrangement. Gotta imagine it would develop the very same bias, wouldn't it? These are different tubes, but more in terms of the number of diodes that are inside these tubes. The operation of the triode, and I don't know, I haven't looked into this, it could be identical in these two tubes, which would not surprise me since it's on its way to driving two more identical tubes. And you would just imagine it to be identical. The circuit appears to be identical, the grid circuit. For a while I was suspicious about these shielded capacitors, but they seem to be okay, and I don't have any reason yet to change them out. But there's still a bit of a question mark around these because they're the old beater type of capacitor. They're only in there because they have a shield on them, and you know, how am I going to duplicate that? I don't have any shielded capacitors here to stick in offhand, so I've left them for now. Maybe that's part of the picture here. In a lot of cases, the capacitor feeding a grid is a blocking capacitor. It's blocking plate voltage from back beyond. I don't think that's the case with these. I don't think there's any DC voltage pressure on them. Perhaps I'm wrong in that. I'm quickly scanning all the way back to this. All the way back to where? Okay, stop the scanning. So we're feeding in the signal here. Everything is passive all the way to this tube. So there is no plate voltage back here. There's no tubes back here. There's nothing back here but the signal coming in from the phono input. So that's kind of the story. I'm happy to kind of go over it for my own sake. Find myself thinking about this now at all times of the day and night. What could be going on? And I think my only move is to repeat the test, collect more information, find out if I booped up. There was a time where I had discovered the high voltage on this tube, the inappropriate high plate voltage, and then I discovered it was not. I think I just accidentally tested this tube again, part of the confusion I was running into. Where's that confusion coming from? I hate to say this, but you see how these tubes are on here? And you see how they are on here? They're actually like this. So, I've been looking at this diagram, and unfortunately my rat brain or lizard brain has accidentally assumed that what's here is here, and that is how I've gotten. Yes, I've let my lizard brain get into control here. So that's the story. So I'm going to start this radio up. I think what I'm going to do first is I'm going to do a voltage measurement all the way around. Maybe I'll try it with a couple different meters especially when I get to the grid. And did I really say the results of the grid bias test? I didn't really say the results. The results were on the tube, which appears to be just fine. Now, how do I know that this tube, you can hardly see it here, that this tube is working and everything? At one point, and I think this is on a video, I pulled it out and the sound disappears from this radio. It's done. So put it back in, the sound comes back. It doesn't matter if you have this one in or out, it doesn't make any difference. So that's how I know for sure that the problem lies in the tube circuit that this tube is in. Absolutely for sure. Nothing is for sure. Yeah, nothing is ever for sure. Okay, that's what I'm going to do. So we're just going to start with this meter. It's a perfectly good meter to use. And we'll go around and take some voltage tests. I'll record them and see what happens. And I'm going to keep the video going today. But I'm going to stop just now. Okay, so I'm ready to go. I'm going to start with this tube. Wrote this chart, exciting chart. Going to write the voltages beside there. And then all of a sudden a light bulb went off in my head and said, one of the reasons a tube wouldn't pass current is if its heater's not heating. So I had this radio on now for 15 minutes, maybe not even that. This tube and this tube are quite similar. This one's plenty warm here, plenty warm. This tube is cold. This tube's not getting any heat. There's no heat. That would explain it. I didn't think of that until just this moment. Okay, set this aside. No heat. No heat in them there heater. That would explain it. That would explain it. Okay, I'm all excited. A little dangerous to do this work when you're excited. Not dangerous, well, yeah, a little bit dangerous in the sense you might get hurt, but more dangerous in the sense you're going to not think so straight. Always a danger with me. Okay, so the tube is this one. EBC 81. 4 and 5 are the heaters. Let's find out. Isn't that something? You know how I got to that? When I was writing down the numbers, I thought to myself, well, 2 of these are the heater. Who cares about that? Ding, 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 ding. The bells went off at that point. What number did I say? 4 and 5. So we're up on the tube extender here. I wish I could make that just a little easier to see. That's not bad. That's not bad. 4 and 5. They're going to be a 0. It's going to be a 0. 1, 2, 3, 4, and 5. I wonder if anybody has guessed this. It's a 0. Tain't no heater voltage there. Okay. I think I hit it. I think I got it. We just have to figure out why is that. Why would there be no heater voltage there? So I'm going to get the schematic up here on the screen. Okay, I just took a quick look at the schematic. Pin 5 goes to the supply. Pin 4 should be grounded. Pin 4. So we'll go like that. We'll go like that. Pin number 4. The ground is off. Pin number 4. Now another pin that's grounded on this tube is the cathode on pin 3. Cathode on pin 3. 4, 3, 3. So you see, I checked the cathode and found it grounded. That's true. I never thought about now checking the heater. Now if we go till just now, so if we go between the heater and the cathode, there should be a 0 there. So somehow I'm probably responsible for this. Somehow. Ooh, let's just keep this tube. I'm going to put it right back in. Well, I'm excited. The breakthrough has come. In all the years I've been doing this, I don't think I've ever found a radio with a heater that's not getting its supply. I don't think it's ever happened once. So, now, I'm going to take a wild bet here. Somehow I desoldered it in the course of doing capacitors. Not sure how that could be. Up you go, up you go. A little crazy working on a turntable. Okay. Now, somewhere, one of the reasons I haven't been doing a lot of voltage checks from under here is I find it really hard to sort out this kind of circuit board. Kind of find my way around it. Even the tube sockets, which are so readily apparent in most radios, I mean, it's really obvious where they are because the terminals are sticking out. It's not so obvious on here. So I'm going to put my finger on the tube. I'm going to say the socket is right under here. Did I do any soldering in that area? I did do some. I did do some soldering. Let me just get a pointer here. I remember trying to work up under the on-off switch. Now, is that part of the tube? So the tube's coming around up here, so it's not actually part of the tube. Not to say it's not involved. Did I do any? I don't think I did any other soldering in here. So let's figure out which one of these pins. I've identified pin number 4 as the problem pin. So if we count them, this would be pin 1, 2, I guess that's 3, and that's 4. Wow. Well, I don't see anything here. Cold solder joint. So something like that. These wires are in the way. Fill those up. And I don't think I can do much with this stiff cable here to get in there. Move this wire out of the way. Move that out of the way. Let's count them again. Now they're in the way. So 1, 2, 3. This is pin 4 here. Very certain I didn't solder with that. I soldered this. This doesn't look so good. What's the action here? This doesn't look so good. Don't know how they relate exactly. Let me get my close-up camera. Where are you, Mr. Camera? See where you are. You're staring at the scope. Okay. Hoping the focus is acceptable here. Maybe not. Okay, let me adjust the focus. Oh, there it goes. There it goes. Blimey, there's a hole there with solder around it and nothing sticking through it. In the what would be the grounded area. So it could be these two pins are not tied together. The cathode and the heater pin, they could find their separate journey to ground, and then this big area must be ground. And there's a hole there. Okay, just to be exact here. We're looking at, I don't like autofocus. Looks like a little bit of weak soldering in here too. I think that's me there. Don't push too hard on this radio, it'll tip right over. I'm just double checking the count on the pins. 1. Whoa, this is 2. That's 3. That's 4. 4 has a little piece of wire here going somewhere. This one has almost exactly the same looking thing. They just little jumpers to here? Why? No. Why wouldn't they just have this solid? I don't know. Who knows? Okay, so we're going to test this from below. See what we get with the ohm meter. Trying to make sure I'm not counting these wrong order. We'll test them from above too. Can't. We're going to test it from above, below, left, right, center. I'm filled with hope. Okay, so I'm gonna, you know what I'm gonna do? Because I gotta have a free hand to catch the radio if it tips over. I'm gonna clip this ground lead, or the black meter lead, to the chassis. That word ground is terrible. It's too bad that North America adopted the term as a kind of a general term used all over the place. I know in Britain they like to say earthed. There's no doubt when you talk about an earthed thing what you're talking about. Okay, test probe in the hand. Counting again. 1, 2. Oh, wait, counting wrong. 1, 2. No, I'm counting right. 1, 2, 3. This is 4. It shows a ground. This is 3. Shows a better ground. 3 is, assuming the radio is wired exactly as the which it should be, because it's not really wired. It's into a circuit board. 4. So there's a capacitor on 4 which is grounded on the far side. That capacitor was shorted. That would put a ground. I would put a ground right across the heater string. That would lead to an obvious, serious problem. I don't think that can be the case. No. Oh, you know what? We're looking at the wrong tube on the schematic again. Oh my God. Looking at the right tube. So cathode and 3 is the ground. Oh no. Yeah, 3 is grounded, 4 is grounded, 5 is going to the heater supply. 1, 2, 3 is grounded, 4 is grounded, 5. Can this be going to the... This is a great big ground piece here. What have I got myself into here? Am I not seeing pin number 1 properly? There's a great big gap here. Okay, I got to test on both sides of the radio at the same time. Strikes me this is the same place on the tube extender I was testing. Okay, just kind of eyeball it over. There's no chance I got the wrong socket here. So we've got 2 output tubes over here. The other triode is located here. This is definitely the correct tube. I'm just trying to be super duper sure of everything now. Okay. I'm going to pull this out before I end up knocking the radio over. That was the phono input plug. I'm going to go up here. I'm going to stick my probe into pin number 4, the one that I'm suspicious that is not grounded, pin number 4. The tube is in the socket. I don't think it really matters. And I'm trying to read these little tiny numbers. Don't want to get it wrong. This is a great great magnifier. This is the lens from a small camera, a video camera of some sort. I've had this for years. This is just a great magnifier. I gotta get my eyeball right in there. Did you know the proper way to use a magnifier is not to say you want to magnify that. It's not to hold it like that and try to see it. That's the wrong way. The right way is, think about the jeweler. Where's his magnifier? It's right up against his eye. So literally you put this up against your eye and then you zoom in by moving in on it. Like that. That's the proper way to use a magnifier. Can I zoom in? I might not be able to get all. My head's too big to fit between these tubes. Let's see. So very clearly 654. 4 is the one right near the little divot there. Put this on 4. 4 would look to me to be this pin, just looking. No, I want to grab where's my other lead? Other lead is over here. Oh, come on, Peter. This meter times out no matter what. It's not like most meters where if you use them, they stay alive. Are you 4? Are you 4? Are you 4? So this is the big ground area. Wait a minute, didn't I read this from above and get no ground? That got me all excited. Oh my God, here it's starting already. It's already started. Conflicting measurements. This is saying it's okay. Well, it's really okay now. Look at that. I got a 0, 0, 0 there. Zero everywhere you look at it. Oh my God. And I've already drank a fair bit of coffee too. I don't get it. This is definitely pin 4. Well, okay, let's go on pin 5. Pin 5 is, looking at the schematic, I'm not on. Pin 5 should be conveying the 6.3 volts to the heater. Pin 5 would be this one. Should get a 0 through it. Should not get a 0 here. It might be close to 0. So I think to some degree we're measuring the resistance of a winding. This is pin 5. This is straight through. Wow, these are not lining up from, am I counting this wrong? These are not lining up at all. I am able to look at both sides at once. It's way off. What the heck am I doing? 1, 2, 3, 4. 5. What has happened to me here? Pin 1. Let me pull the tube out and look at the shape of the socket. See where the gap is. The gap is exactly where I see it. The pin gap, where you can start counting from. Count this way when you're looking at the bottom. 1, 2, 3, 4. 4 should be if I had to look from the top, I would say it's this one. There must be two pins under here. I'm counting wrong. Okay, moving this wire. Too bad for it. 2, was hard to see on the camera there. I didn't realize that. It's a little far away. There's the ring. There's the center post. So maybe that's a good thing to look at. The center post for the socket in the ground. There's the last pin 9, first pin 1. 1, 2, 3, 4. Well, then this is pin 5. Well, it really looks like part of the ground, you know? Okay, for sure. Isn't it? Isn't it? Isn't it? Holy smokes. This is really ridiculous. Okay, so calm down, take your readings again. Checking to make sure that, yeah, I have this connected to the chassis. Stating what each pin is. Pin number 1 is the plate. It doesn't make sense to test it to ground. Pin number 2 not listed. Pin number 3 is grounded cathode. 1, 2, 3. Grounded cathode. Can't see the meter there. It's at 0.9. Grounded cathode. 1, 2, 3. So 0.9. Is that what ground is turned into? Yeah. So 0 is 0.9 at the moment. We go to 4. There we are. Now she's open. It just really doesn't take much to confuse me. That's what it must amount to. There's 4. Of course, I have the tube out. When the tube was in, the heater was shorting it. Da-da-da. Okay. Now I think I know what I'm doing. I think I know what I'm doing. Checking the ground again here. Yep. 0.9. Okay, so somehow this thing is not connected. Now, if we look here, so there's a wire, a yellow wire and a resistor. The yellow wire goes a little further than the resistor. Okay, so I think the resistor soldering is here by me. I think there's probably 2 holes, and that's the resistor lead there that I put in. So it's soldered okay. The hole is immaterial. The pin has to follow this yellow wire. But I didn't do any soldering on this yellow wire. The yellow wire extends across the top of the board over to here. Oh my gosh, it looks like. What's it look like? Looks like we need the close-up camera to look at it. So I think I'm looking at the other end of this wire here. So we'll take a look at this. You know what? I'm going to fix the focus on this camera because this is going to drive me nuts. Otherwise, I just have to aim it at something correct. Bear with me while I'm simply calling up the dialog box for the camera. Like the properties dialog box. I'm going to turn off auto. I'm going to zoom it up about like that. That's much better. Okay, so we're looking at 2 similar looking pads there just behind the black wire. The upper pad is number 4. It should be grounded. It's hard to see in the camera, but on the right side is the socket pin, and on the left side is the tail of a wire. That wire goes across straight as can be and arrives at this schmozzle here. this wire back down. Okay, so there's a couple things on this that don't look all that good. I think it's nothing more. There's cracked solder in here. Look at that. Now, see if I can point to it. What I've spotted is the cracked solder here. And up here. These two things are cracked. Are they cracked enough to cause a problem? Are they related to this? I don't think so. The one pad is just there all by itself. What is that? So I'm looking up. You know what that is? Oh my gosh. Oh my gosh. That is the socket pins. Hang on there, Peanut. It's the socket pins for the output tube, one of the output tubes, which run hot. Oh my gosh, so that's interesting. Now that one that appears to be isolated probably is. Probably does nothing. But look at the one above it. It's cracked. That's what I say. I say, So maybe the wire one has taken a beating too somehow. Yeah, I know you're here, Peanut. Come on. Okay, so name of the game is whip the soldering iron around in there, resolder a pile of stuff, and try not to desolder anything by accident while I'm resoldering it, and then we'll give this thing a try again. Are you agreeable, Peanut? Yeah, well, he's got a real look on his face. I better hurry. Okay, finding some interesting stuff here. Well, that was very interesting. I went off with my cat, Peanut. Sat on my lap for a few minutes. He didn't really get very comfortable, as he usually does. And then he got up and disappeared. He went upstairs. And he came back downstairs, started meowing at me. And he disappeared again. I came in here, just about to started meowing at me. And I suddenly realized what he's meowing at me about is my other cat, Shadow, is in the garage. She likes to go in the garage, and I forget about her all the time. So I went to the garage, opened the door, in comes Shadow. The two of them greet each other, and off they ran together. So Peanut was trying to tell me that Shadow's missing. He's gone around the house looking for her, can't find her, and he's coming down and saying something's wrong. He hasn't got a lot of words, you know. So, and from the cat's point of view, us stupid humans, man, we're really thick-skulled. What should be obvious never is. That's how it looks to them, I think. Okay. So what I've done is I've hooked up my ohm meter here on pin 4, showing an open circuit, and I'm going to wield the soldering iron and watch for the meter to suddenly announce success. Let me relocate where I'm going here. Going up in this area. So I'm going to pile in a bit more light. Okay. Make sure this is fairly visible. Yeah, that's good enough, I guess. Okay, soldering iron, and I'm going to need a little bit of solder probably to wet the iron. Which one's going to do it? I'm going to try to do it. Well, first I'm going to go after those cracked ones. The cracked solder joints, which that was part of this tube's way up here. I'm going to have to get the magnifier out and identify them again. So the wire, I think I am totally lost here. So, right, the wire is up in this area here. Okay, watching that meter. This is the one I think it is, right here. There's nothing happening. Okay, I need a little bit of solder here. It's not that one. Is it this one? Push this radio right over. Okay, I'm going to take a look from above. Just melting this one off. Didn't do it. Okay, looking at the wire from above, it's way, way over on the very edge of the board. Jeepers creepers. Jeepers creepers. Okay, so I put my finger on it here. Gonna move a bunch of wires out of the way. There's no way I was up there with a soldering iron. Let's look in there. Let's take a look in there. See what can be seen. So I'll put my finger on the wire again. I should have kind of tested the wire. Maybe I'm going to end up doing that. I may have jumped over a step. Oh my gosh, it's right where those cracks are. In fact, you see the one above, the cracked one above? That looks like a stranded wire. And that's, I think, what I've got here. So it's the cracked ones. Isn't that a tube terminal? What am I actually seeing there? This looks like some kind of crystalline growth on the... and I think this is right on the outer edge of the board. Just below it is a connection that's further to the edge. Oh, I can't really see in here. Well, let's get the soldering iron right in there. So now I gotta look with my own eyes and figure out where that is. Okay, I see it. We'll go back to the other camera. This is the moment of truth coming. Get my finger on it again. I spy it. Oh! What's the meter doing? How did it do that? Is that for me wiggling this wire? It's from me wiggling this wire. We're really on the money here. Okay, first this one. This is the one that appears to go nowhere. Okay, and then the one that would be just below that, I think. Right in here. Burning the wire. Burning the wire. Get that out of the way. Kind of plastic smoke in here, which I don't appreciate. Breathing. Okay, right in here. Melt that guy. Not exactly zero, it's something different. May not have gone quite far enough back there. Burning the wire. Hoping for a zero to appear. Got something quite different. 98 now. Is that because maybe I don't have a good... That's open. This is too flimsy. Too flimsy a deal. Down to 12 ohms. Let me look in there again. The upper cracked one. I got, see my my fooling around there. The solder. Wiggle this wire. Oh, it's definitely having an effect on the meter reading. So I can't believe I'm not locating it right. Okay, I'm going to get the other cracked spot. Maybe it's the other side of a component coming from here or something. I don't know. Got to get rid of all the crack stuff. Okay, so crack stuff. There's another wire in the way. Learned my lesson about holding a soldering iron while you work another tool. You can only pay attention to one thing at a time. I'll move this wire way out of the way. We have a clear shot to the cracked second, the upper crack, the upper cracked thing. Thing. How many more cracked things are there in here? I think I need to add some solder to the experiment. Don't push the radio over. Shouldn't. I hear clicking coming out of the speaker every time I touch this. That's not made it. Okay, a little extra new solder on this other cracked guy. Still not there. Okay, sorry, I'm going to have to show you my shoulder while I do this. See in here. What's going on with that? It must be very close. It's very strange how that's working. This one way down here. Don't push the radio over. Still a 0. We have to test the wire. No, that's really liquefied in there. That's good. Did you see that? It's good for a while. That could just be that my meter connections here are just not up to the job. I'm using this red clip lead. Let's check this red clip lead. Good, as long as it stays connected. Yeah, I think it's good. She's a good one. It's going to the here. Okay, now we'll check that connection to the. Yeah, this isn't reliable. It just totally disappeared. See if I can make a better connection to the, you know what, I take the tube extender out. It's easier to go right into the socket. That's a good idea. Okay. One, so it'll be 1, 2, 3, 4. Yep. out. You know what? The socket is not easy to go into, because it has a shield around it. Well, I can still stick something down in there, for crying out loud. For crying out loud. Will this go in? I think these are too big. Let's take a look. Counting 1, 2, 3, 4. Yeah, so I can't really push that in. I'm going to find something I can push in there. Even just like a nail. Often right-sized nails are good for this. I'm going to find something. Okay, I think I got a much better setup here. Just check my meter out. 0 is now 0.1. I have a nail in pin 4 in the socket with a clip lead on it. And first I'm going to push on the wire, the suspicious, oh my gosh, I just barely touched it. The suspicious wire. Or is it this? Is it this? It can't be this. This is doing nothing. The wire is really the thing. Okay, I got my finger pointing at it. It's all those same connections. Soldering iron still hot. My finger back on it. And you know what I'm going to do too? I'm going to put on my magnifiers here. I'm pretty sure I'm going to get in front of the camera, but so be it. You're seeing the more attractive side of my head anyway. Okay, number 1. Why did I say that? I don't know. Oh yeah. Magnifier on. So this has got a solid lead in it. I don't think it can be the wire. Am I getting anywhere? No. This, I think, is the wire right here. It's all melted up. Didn't do anything. Okay, we need to track something back. Maybe I'm wrong about this wire. So theoretically, with the pin in, with the nail in pin 4, I'm on one end of this wire. Why would they even do this? Why would they bring a ground wire way over here? Doesn't make any sense. Put the other lead. Try to touch the conductor of the wire. It's going to be a little tough. Oh no, it's sticking out. The meter's not responding. Okay, so now I'm going to go in and try to. This is pin 4. We should get a 0 there. Not quite 0. This is pin 3. And the same thing. That's ground. This big sheet is not ground. So there's a big area here of trace. Goes all over the place. Widens out to fill all the space, so that's got to be the ground. So now the ground is 0.2, 0.1, get down to 0.1 still. It's not quite the ground. Cold solder joint up here. Is that really the wire that I saw, which doesn't make sense to me? Why would they ever do that? Could be a resistor there. Shouldn't be any resistor. Shouldn't be any resistor there. This is supposed to go straight to ground. The way they've shown it, it's actually connected to the cathode lead, pin 3, and grounded from there. I didn't see that in here. Okay, let's just, for the sake of eliminating things, some kind of a cold joint that doesn't look like a cold joint. I have to examine those cracked ones and all around for more cracked stuff. Let's just do this. This is pin 4. Getting heated up and resoldered. Can I lay this thing right on its back? I might be able to, you know. I may end up doing a lot of soldering in here. Then that's probably what I'll do. Oh, for crying out loud, soldering iron's timed out. Why is this going so slowly? Okay, resoldering the pins on this tube. At least pin 4. There we go, all liquefied. Meter doesn't do anything right now. And the solder has funny shapes, and when it's new it reflects, and if it's concave it can reflect and give you the impression that there's something there floating above it when there isn't. So I find it really hard to look at these things. In my old age, that's what it must be. Okay, so let's check and just see where we're at here. So from pin 4 to the chassis. Getting nowhere. Checking to make sure the clip lead and pin 4 is still in. Yeah. Taking a reading to the other side of what I think is pin 4. Yeah, you're kidding me here. Meter stop. No. Nothing coming through at all. What's happened here? So this is the kind of stuff I tried to avoid posting in the last video, except it was just like this, only I was on one tube thinking I'm on the other. But lots of really fiddly testing with this. I think it's my pin contact is crappy. I'm waving it around and it's doing all that. Is there like just basically a socket problem here? Is that what this is? A socket problem? How can it be a socket problem? I need something. Pull out the nail. If I just shove the meter probe into the socket, it will make contact. I'll hold it there. Pin 4. That's definitely pin 4. Okay. I think this is pin 4. That's good. I think pin 4 is hooked up to a wire that comes over to here. Good. I think pin 4 is supposed to be 0 to ground. Okay, well, what exactly is happening there? So I'm moving the test lead around in the socket a little bit. So the wire, the end of this wire is here. I can't see the meter. There it is. So that looks like that's true. Pin 4 is hooked up to a yellow wire that runs all the way to the back. So if I get on the right piece here, we should see the same reading, yeah. Maybe the radio's fixed and I don't realize it. I'm just struggling with stupid measurements now. So, maybe I got it. Let's take a look at those cracked. Let's look into this whole cracked thing at this point. Examine the. I'll try to examine all the solder that's involved with the 2 output tubes. So, okay, so we're looking at one here. Also see what I've done with my soldering iron. So. There's the 2. They look terrible, but they're not cracked anymore. It all looks pretty horrible in there. And down below. So the one that has the yellow wire, I believe, I'll try to put it dead center of the screen there. Okay, let's follow around the other. So I'm looking around at the other. They all look cracked to me. Oh my gosh, look at that. All cracked. I don't know if you can see what I'm seeing, but... Okay, now the other output tube is just beside it. It's a little bit easier to see. I'd say they're cracked also. Now, just because they're cracked doesn't mean they've lost contact, but they're on their way. And it would be very hairline sort of stuff. Maybe start introducing a resistance here. I guess in the right spot, a little bit of resistance goes a long way to messing everything. Now, there's a lot of terminals here, they just don't seem to go anywhere, but they're soldered in. So if those ones are cracked, it doesn't really matter. Okay, so I'm going to have to resolder all those connections. Okay, that's the name of the game. Resolder all the the socket terminal connections for the 2 output tubes, which run hot. Okay, so I think I did that soldering, but all I'm going to do is I'm going to scan this whole board very carefully for any more areas that might have cracked solder. My cat, what is with you? I can't make spring come. Okay, I can't do it. What am I looking at? I'm looking at... I missed it. This is one of the output tubes. Got a chicken scratch around there too. Man, I gotta do those again. Now I've got the radio on its back. It's a lot easier for me to see things and to work. I don't have to worry about it falling over. I don't see anything in this quite as bad as the ones I discovered. Excuse me. It doesn't look terribly good there either. So I know, a procedure that can be performed on these radios is just a general resoldering of all connections, and I think some people do that. I would be hesitant myself because there's a possibility of introducing a problem, a good possibility. Solder bridge, or to actually make a cold joint while you're trying to fix one. Well, nothing much turned up there except the same sockets again. Maybe the socket of the tube that I'm working on. So I'm going to go have a little chat with my wife. I'm going to wield that soldering iron, solder these things up and try to make them disappear, and then see if tube heats up after all that. Okay, I think it's time to give the radio a shot. I've plugged in the tube, the switch on mono, and the output from the signal generator hooked up to the phono input. The volume turned down. Okay, we're going to put on the power. How do you like that? How come it came on? I don't have any buttons pushed. Push this one. Maybe it's a false button pop. Now these radios, you can push 2 buttons down at one time. You can do various things to them. I'm not recommending it, but buttons, I really meant one finger to do the thing here. And sometimes a button can pop up but still mechanically electrically still be in its other switch position. Okay, everything seems good. I don't see any problems, even though I did all kinds of soldering under there. Didn't do all kinds. I just soldered the things which looked like they needed it. Now, can I see that tube glowing? Pretty tough, pretty tough. Speakers are connected. Okay, something's working. Let's put a little more input in here. One channel, other channel. Still not proper. So I'll bet you that tube is still not heating. This could just be the simplest thing. How can I tell? How can I tell for sure? Wait a while and see if it gets hot. That sounds like a long process. Pop it out, put in the expander, look for the voltage. I don't know what to say about that. Felt a little bit like it was warming up. I'd say it's warming up. I would say this is warming up. Put it back in. Oh no, you know what? Put in the extender so we can read the actual voltage, because maybe now I've got a high resistance. It's kind of a dumb. I did not get a shock there. I just got the. I'll have to clean my pants later. I did not get a shock, but boy, I was close. Stupid thing I did there. Stuck my finger on top of the tube extender and it's full of terminals. Okay, I'm going to turn off the speaker that's working. Yeah, they're both working. Wait a minute. So again, this sounds like it's balanced now, but this is at the extreme. Okay. Let me get rid of this speaker. Well, we're ahead in the game. There's something. But just, I don't want something, I want it all. Now, is it within the balancing range? My speaker, I'm using 2 identical speakers, but they're not fed with the same kind of wire. Fairly long wire, it shouldn't really matter. Okay. Both speakers connected. It's quite right. Put it on stereo. Oh. Back to mono. I'm not sure what to think now. Let's play the radio here. We'll just pick broadcast. Oh. That's the balance seems to be way in favor of one speaker. Let me flip the speakers around. So the loud one's on my left. I'll change these left for right and see if the loud one is on the right. And that'll identify the speakers as being the cause. Well, that's pretty good. That's pretty good. I think we're there. I think we're there. How could I even more prove this? There's no headphones output. Hooking it up to the real speakers. That's not going to happen easily. It's not going to happen. That's too much effort. Can't really tell with those speakers. They're pretty close together in the cabinet. Make sure I've got my head in between these two speakers properly. Well, I think we got it. I think we got it. Measure the plate voltage here. That would be a good idea. That would be a really good idea. The plate voltage comes out at 60 volts. We're done. Okay, so this will be on pin number 1 of the correct tube. Pin number 1. 60 volts. What do you say? I think this is pin number 1 here. Look at that! Doesn't matter that it's negative. How do you like that? I like that. Okay, we're going to call this solved. Maybe other issues that are causing a little bit of imbalance in the signal. But if they are, they're minor. They're certainly within the range of this. There's no question you can balance the sound. You know what that means? That means I'm done for today. It's now lunchtime. I feel good about things once again. Get back to wrestling with the FM and AM radio. Fantastic. Well, there you are. You just, this is, and you never know what you're going to be up against in these radios. Great. Thanks a lot for watching. And tomorrow we'll get back to doing some more, I don't know what to call it, electronic sort of work instead of looking for these mechanical type problems.